Welcome to this session and to reInvent 2020, our first global virtual conference. Just like this conference is virtual, this year we saw many aspects of our lives turn virtual. And this time last year, at last year's reInvent, we couldn't have predicted how much the world was about to change. So here we are in this new age with many aspects of our lives turning virtual. And whether it's out of safety or convenience, or both, we have and we still are reinventing our lives to embrace virtual experiences as the new normal. We've been seeing use cases expand and develop, and when it comes to business, live virtual events can be used to facilitate agreements and to make decisions. For example, placing a bid in a virtual auction, giving an answer in a virtual exam, accepting an offer in a virtual property tour, or casting a vote in an opinion poll during a live broadcast. So now the challenge is, how can we convince anyone who joins and participates in a virtual event that the transactions they're seeing are authentic, have not been tampered with, and can be transparently and independently audited? To put this into perspective for you, now that you may be thinking about hosting or already hosting your own live virtual events for your customers, how can you create a trusted environment so they'll want to keep coming back? There are two aspects when it comes to a trusted virtual event: who the participants are and what the participants do. In today's session, I'm focusing on managing what the participants do, how managing the data, and how agreements and decisions can be captured from a global audience and stored in a way that's trusted. And there are two services that can achieve this depending on the use case. It's either Amazon Quantum Ledger Database, known as Amazon QLDB, or Amazon Managed Blockchain. So the agenda for today, first I want to talk about the timed metadata API in the Amazon Interactive Video Service and show you how you can use this API to interact with your audience during a live event. Then I will walk through two reference solutions. First, a live virtual auction using Amazon QLDB, and secondly, an interactive live voting solution using Amazon Managed Blockchain. Now, if you haven't had a chance to learn about the Amazon Interactive Video Service yet, also known as IVS, it launched this July and it delivers low latency live streaming. And when I say low latency, I mean as little as 2 seconds delay between the host's video camera and the viewer's screen on the other end. All of the complexities of live streaming are managed for you, like transcoding, the global content delivery network, and a video player for web, iOS, and Android. And the way that you interact with your audience is through the timed metadata API. For example, you can ask the audience a question, or you can stream metrics and data to enhance what they're seeing on screen. So here is an example of one sequence of interactions. In this scenario, a broadcaster is asking the audience to cast their vote in an opinion poll for either Team A or Team B. The first JSON payload contains a prompt for the viewer to cast their vote, and this payload is injected into the live stream using the timed metadata REST API. The question is then rendered over the viewer's video player. The next two JSON payloads show the results as they're being calculated in real time, and these are displayed as metrics. These metrics can continue to be reported in real time through the timed metadata API at up to a pace of 5 transactions per second. And this limit really makes sure that the metadata that a viewer is seeing on screen is still humanly readable. So let's move on to two reference solutions. First, let's think of a type of auction where people would have previously physically attended, like a property auction or a classic car auction. And how can we recreate that experience virtually and keep the bidding process trusted? So here is one way to do it in this reference solution. A live virtual auction is being hosted with a group of pre-registered bidders, and they'll join a video conference together with the auctioneer. The auctioneer is going to broadcast the auction to spectating viewers using IVS. And starting from the top left, a bidder places a bid through the AWS AppSync API to write the record, the bid record, through to Amazon QLDB via AWS Lambda. In response, Amazon QLDB returns the bid confirmation as an identifier, two identifiers that can be used to cryptographically verify the record and audit it later on. And in the coming slides, I'll show you how this verification is performed against the data. Now, as the auction progresses, data about bids being placed are reported in real time to the viewers, both the bidders and the viewers. The bidders and the auctioneer have a leaderboard through AWS AppSync, a comprehensive leaderboard. And the broadcast viewers are seeing a simplified view where they're visually seeing bids being placed as metadata that's rendered over the video player of their live stream. To stream data from Amazon QLDB through to IVS, we're using QLDB's streaming feature that writes real-time updates about bids being placed and streams these real-time updates through to Amazon Kinesis data streams. As a consumer of the stream, AWS Lambda will read and batch the records and insert them in real time to IVS using the timed metadata API. I'll show you shortly what this looks like in a demonstration, but first I want to dive deeper into the trust and transparency aspect of this solution and what it means to say that bidders receive a cryptographically verifiable hash. So each bid placed can then be verified against Amazon QLDB through the hash calculations in 2 steps. And to complete these steps, there are 2 values that you need that describe the record of the bid that you're trying to verify. So when you place a bid, you receive a document ID showing, which is a unique identifier of that bid. It's assigned when a new record is appended to the ledger. In this case, each bid placed, assigned, is assigned its own document ID. Secondly, there's a block address, and this represents the position of the record in the ledger, the block number. So to verify the bid, it's a 2-step process. First, you need to generate a digest. The digest contains a sequence number of the last record in the ledger. If you visualize the ledger like a list or a series of blocks, a list of blocks, the digest is the last record in that list, or the last record in that list of blocks. So this sequence number is the final record at that point in time. Also, a hash calculation of all bids placed is returned from the digest, for the digest. And I'll show you in a few slides how this hash value is calculated. And then in step 2 is where the verification actually takes place. And verification is done through a series of calculations to compare hash values between the bid record and the digest. So let's move to a short demonstration of the live virtual auction. The active bidders join on Chime. The spectating viewers of the auction are streaming the live broadcast, which is the video player view, the large video player view that you can see on screen. In this conceptual view, I'm showing both Amazon Chime at the top and IVS in the same view. The auction starts and the bidders come into focus when they place a bid. As the active bidder, when I place a bid, you'll see two values returned. You can see the two cryptographic values on the right-hand side returned to me on screen. The first is a document ID and the second is the block address. You can also see the real-time updates after I place my bid. The overlay on the video player has real-time updates that are coming through the timed metadata API about bidders and the value of the bids that they're placing. Now let's move to verifying the bid. You can verify by using the QLDB API or the AWS CLI, but today I'm going to show you how to do this in the AWS console. I've generated a digest and I've entered my document ID and the block address into the console. You can see that my calculation was verified successfully. And you can see the series of proof hashes between my bid record and the final digest, the last record in the ledger. And this shows the working calculations in detail. So back to this solution, it achieves transparency because when bids are placed, they can be broadcast with identifiers that can be used to verify the record and prove the record is authentic. So next, let's look at how the records are stored in the ledger and why this can be trusted. First of all, in a ledger database like Amazon QLDB, records are immutable, which means that records can't be altered. They can only be appended. Updates and deletes are actually appends to the ledger, and the record contains a record of the deletion or the change in the data taking place. You can't go back and change a record because each record in the ledger is linked together by a hashed value of the previous record, and this creates the chain. So because the chain is linked, trying to rearrange the order of these records would break the chain and would break the chain that links the records together. Also, it's actually impossible to change even a character of the record in the ledger because for each record, a single hash value is calculated using SHA-256 to get a single unique identifier of that record's contents. So that calculation, that SHA-256 calculation, is performed by calculating the complete snapshot of everything about that record, including the SQL statement that was used to insert the data. In this case, QLDB uses Particle as the query language. A hash calculation is also made on the data, in this case, the bid amount and other information about the bid being placed, and the metadata about how and when the record was appended to the ledger. So because these hash calculations are used to link the chain, attempting to change even one character would change the hash of that record and would break the chain. And now let's take a look at another solution. Consider an interactive live voting solution using Amazon Managed Blockchain. Say a broadcaster during a live stream asks their viewers to vote in an opinion poll. They're prompted by the Amazon Interactive Video Service to cast their vote for either Team A or Team B. And in this opinion poll, Team A doesn't trust Team B's count of votes, and Team B doesn't trust Team A's count of votes. Because this is a live event, the votes need to be cast by the viewers, counted in real time, and the progress of the counts reported in real time back to the viewers. So in this scenario for these requirements, Amazon Managed Blockchain has been selected because with blockchain, we're able to create trust in an already untrusted environment. In a blockchain network, there isn't just one ledger database. All members actually keep their own copy of a ledger database in their own AWS environment. So this blockchain network features 3 members: the voters, Team A, and Team B, 3 members in the network. And this blockchain network is using Hyperledger Fabric for the blockchain infrastructure. So let's walk through the solution from the perspective of the viewers in the bottom left. First, the Amazon Interactive Video Service prompts viewers to cast their vote. So the viewers place a vote through an AppSync API, and the AppSync API writes the vote records through to the Hyperledger Fabric client that's sitting in the voters' member network. Amazon Managed Blockchain then takes care of the heavy lifting to distribute copies of these votes in real time to Team A's ledger database and Team B's ledger database. And Team A's ledger database and Team B's ledger database are being managed by each of those teams in each of their own AWS environments. These databases are replicated across availability zones for high availability. Team A's auditors can then inspect votes coming in real time in each of their Fabric client apps, as well as Team B's auditors can do the same thing. They both get their own copies of the data. So each of Team A's auditors and Team B's auditors can inspect the votes coming in real time and confirm that the tallies are accurate. So finally, as the votes are counted and audited in real time, the broadcaster streams real-time results of the vote results from the voters client through to the Amazon Interactive Video Service. I've shown you 2 solutions for trust and transparency, achieving trust and transparency in a live virtual event. One with Amazon QLDB and one with Amazon Managed Blockchain. And just to recap the difference between each service, because the key difference is actually in the ownership of the data and who owns the data, how it's managed. So there's centralized and there's decentralized. We chose centralized for the live virtual auction because bidders already trust the auction house. And the auction house is the centralized owner of the ledger because they've built trust with their customers over years, and the customers trust that they can gain access to verify the outcomes of auctions if and when they need to. For the live interactive voting solution, we selected a decentralized ownership model since Team A and Team B are competing and they'll only trust their own count and audit of data in their own AWS environment. And for both services, when it comes to the management of the data, both of them store data in a way that's immutable, cryptographically verifiable, and scalable across availability zones, and for durability. So for some customer examples, MediSci is using Amazon QLDB to accelerate data verification during clinical trials with patients. In the clinical trial industry, just 1% of data fraud can destroy an entire trial. So with Amazon QLDB's immutable and verifiable transaction log, they have been able to reduce counterparty risk of data fraud and streamline clinical trials so they can create better outcomes for patients. And one customer who is creating trust and a trusted environment with Amazon Managed Blockchain is Sony Music Entertainment Japan. They built a DRM solution on Amazon Managed Blockchain where musicians and artists can confidently publish their creations, knowing that the tracking of royalty payments are automated through the trusted and transparent nature of blockchain technology. This ultimately empowers musicians and artists to continue making more music. So here are links to code repositories and workshops for the 3 AWS services I spoke about today. And for well-architected resources, labs, and solutions, you can learn more by visiting these links. So thank you for your time today, and Q&A will be opening up next.